Hello everyone, I hope you are doing well. Um, in this video, we're going to review for exam 2. There are 25 questions I'll go over. My assumption is you have done all your homework. If you have not done that, then first of all, finish your homework and just come here, print out the review assignments which is available with this video. And if you don't have printer, that is okay, just write down the problem on paper and work with me. Okay, literally just work with me, just write down each problem, each steps, and it will be very helpful, trust me. Okay, let's start. There are 25 questions. um, so I'm going to start with I'm going to start with problem 1. Find an equation for the line tangent to y equal 1 minus 5x squared 83 comma negative 44. Okay, so let me use a blank paper here to work on this problem. So problem number 1, we need to find out the equation of tangent, um, and then the curve or the function we have given is 1 minus 5x squared, and then point where we would like to find out the equation of tangent line is 3 comma negative 44. So let's say this is the curve f of x or y, whatever you say, and there is a line, tangent line at point 3 comma negative 4. We would like to find out the equation of this line. Okay, for finding the equation of a line, you always have to find out uh, the slope, and this is the equation we are going to use for equation of line. Y minus y1 equal m times x minus x1. So here this point can be taken as x1 y1. The thing we need to find out, which is not given here, is the slope of this line. So for the slope means derivative. So if you know how to find the derivative of this function, you can just find out the derivative at x equal to 3. That will give you the slope. I'm going to use limit approach here for finding the slope. And this is the formula I'm going to use. Slope equal limit h approach to 0 f at 3 plus h minus f of 3 over h. We're going to use a very similar kind of formula for problem number 2 and 3 as well for finding the slope. Okay, but keep in mind you can also use the derivative because slope means the derivative for the function. So I'm using this limit definition for finding the derivative or the slope. Okay, so now you need to find out the value of the function f of x at 3 plus h, and value of the function at 3 is already given, which is negative 44. Plug the value here, simplify, and then that will be the slope. And finally, using this equation, we'll be able to find out the equation of this tangent line. Okay, so that's the idea. So I'm going to plug the value here. Limit h approach to 0. f3 plus h is, this is the value of the function when x is 3 plus h. So I'm going to find that value here. f3 plus h equal 1 minus 5 times 3 plus h squared, and I'm going to simplify it. 1 minus 5, this is 9 plus 6h plus h squared. Just multiply 3 plus h and 3 plus h, that will give you this expression. And if you distribute this 5, keep in mind there is a negative sign in front of 5, so 5 times 9 is 45. minus 30h minus 5h squared. And if you simplify this, it will be negative 44, negative 30h, negative 5h squared. So remember, whenever we try to find out this limit, always the goal would be, just cancel out this h from the denominator so that we can plug h equal to 0 in the given rest of the expression. So that would be the goal. Okay, so here f3 plus h is negative 44 minus 30h minus 5h squared. And another thing we need to find out is f of 3. You don't have to plug x equal to 3 in the given function, because we have given this point when x is 3, the value of the function will be negative 44. It's already given. So the value of the function at 3 is negative 44. So we are going to plug these values back in this expression. So I'm going to do that here. Negative 44, negative 30h, negative 5h squared, negative, and f of 3 means it's a negative 44. So eventually that negative and this negative becomes positive. So let's keep continue. And you can see that there is a negative 44 already, and this is positive 44, so they will be cancelled out. So the leftover on the top would be 30, negative 5h, and then I can factor out h. And that's the whole point. Always we try to factor out h on the top so that we can cancel this h from the denominator. And after that, for finding the limit, we just have to put h equal to 0 in the given rest of the expression. In this case, if we put h equal to 0 here, the leftover will be negative 30. So slope of the tangent line for this function at 3 comma negative 4 is negative 30. So now we're going to use this negative 30 back in this equation of tangent line. X1 is 3, y1 is negative 44, and that will help us to find the equation of tangent line. Okay, so I'm going to use different color here. So let me use this one. So I'm going to use this formula for finding the equation of tangent line. Y minus y1 is negative 44 equal m, which is negative 30, x minus x1, which is 3. And now we just have to simplify this. So this is y plus 44. We need to distribute this negative 30 on the right side, so it gives us negative 30x positive 90. And we can simplify this equation further. So let's subtract 44 from both sides. That will give us y equal negative 30x positive 46. So that is the equation of tangent line at point 3 comma negative 4 for this curve, or for this function. Okay, so that's how we can do this problem 1. Let's go to problem 2 and look, as I already mentioned, for problem number 2 and problem number 3, for both of these problems we need to find out the slope or the derivative. And you can use, if you already know the formula, you can use the formula if they don't ask you to use the limit approach, but I use the limit definition for the derivative or the slope. Okay, I'm going to do exactly same here for problem 2. The function is given, we need to find out the slope at point 4 comma 22. So I'm going to exactly repeat the same thing. I'm going to find out the limit. I'm going to use the limit definition for finding the slope, and then same formula as I used for the equation problem 1 for the equation of tangent line. So let's do that for problem 2. The function is x squared plus 6, and then point is 4 comma 22. Problem 2, the function is x squared plus 6, and then point is 4 comma 22. Let me just do the double check here. X squared plus 6, and the function is 4 comma 22. And for finding the slope, m here stands for the slope at 4, so we need to find out limit of this function at 4 plus h minus the value of the function at 4 over h. And by doing exactly the same thing we did in problem 1, find out the value of f4 plus h, f4, plug that value back in this expression. Exactly the same thing. By doing that, I will have this expression limit h approach to 0, 4 plus h square plus 6 minus 22. Don't forget that the value of the function at 4 is, it's already given 22, so I don't have to find it out, over h. If you simplify the top one, the top portion, it will be the top part by plugging the value of 4 plus h square and simplifying, it will be 8h plus h square over h. And now the ultimate goal is factor out h from the top part and cancel out the h from the bottom part. So it will be limit h approach to 0 h times 8 plus h over h. And then finally, if you plug h equal to 0 here, the slope would be 8. And now the equation of tangent line at 4 comma 22, y minus y1, which is 22, equal the slope times x minus 4. Don't forget that the point x1 y1 we have given in this case is 4 comma 22. So let's just simplify this, just distribute this h here. So it is 8x minus 32, and there is a y minus 22 on the left side. Just add 22 both sides, so it will be y equal 8x plus 22. So there are two answers, the one for the slope and another one is for the equation of tangent line. And that's what we have asked here. Slope is 8, y equal it's 8x plus 22. That's for problem 2. Let's go to problem 3. Problem 3 is an object is dropped from the top of a cliff 625 meters high. Its height above the ground t seconds after it is dropped is, so this is the function we have given, the height function, which is the function of time. Now we need to find out the speed, determine its speed 2 seconds after it is dropped. So remember, speed means its absolute value of the velocity. So we have to know that fact. Speed means it's a positive velocity, and velocity means it's a derivative of the function of the position function. So which is rate of change of this height function. Okay. So to find out the derivative, which is we can use the limit definition, or you can use any other formula for finding the derivative of this function, but that gives you the velocity. Here we're asked to find the speed, so whatever velocity we get at 2, we have to make it, if it's not already positive, we have to make it positive to find out the speed. So let's go to next page, and I'm going to, so remember this function 625 minus 4.9 t square, and then the speed we need to find is at 2 seconds. So let me use another blank page here. I'm going to add another blank page. So this is problem 3. Problem 3, the height function we have given is 625 minus 4.9 t square. 4.9 t square. 4.9 t square, and we need to find out the speed at when time is 2 seconds. Okay, so this is the relation you have to remember. Speed is equal to absolute value of the velocity, and velocity means it's the the derivative of this function. And for finding the derivative, I'm using the very same idea, limit of this function at 2 plus h and f of 2 divided by h. I'm going to use the same idea. Just plug the value of this function at 2 plus h and f of 2, and then just simplify it, and this derivative would be, so let's plug the value. F of 2 plus h is equal to 625 minus 4.9 2 plus h squared. So we can simplify this. 625 minus 4.9. This expression is 4 plus 4h plus h squared, and it's a 625 minus 4.9 times 4, which is what is that? 4.9 times 4 is 19.6, and then minus it's 19.6h minus 4.9 h squared, and f of 2, we can simplify this. 625 minus 19.6, which is 605.4, 605.4 minus 19.6h minus 4.9h squared. If you try to find out the value of the function at 2, which would be 625 minus 4.9 times 2 squared, which is eventually it will be 605.4. okay, so if we plug this value back here, you can see here 605.4, 605.4, one would be positive, another one would be negative, so you can cancel that, and you have to factor out h. So eventually, so the derivative at 2, the derivative at 2, it should be at 2, is equal to limit h equals to 0, this expression, which is negative 19.6h minus 4.9 h squared divided by h. And if you try to factor out h from the top and plug cancel out the h from the bottom, and finally plug h equal to 0, the derivative would be negative 19.6. Make sure that this is the derivative, which is actually the velocity at 2, but speed means it's a positive velocity. So the speed when time is 2 seconds would be positive 19.6 meter per second. So speed is equal to absolute value of this, which is 19.6, and then unit for the speed is meter per second in this problem, because we can always go back to the problem here. It's a meter per second. Okay, simplify your answer. So that's the problem 3. Now, by using the same limit approach, we can find out problem 4. In problem 4, we have asked to find out the derivative and then slope of the tangent line. Remember, the derivative and then slope means the same thing. So first we're going to use a limit approach for finding the derivative, and finally we put x equal to negative 5 in that limit. So let me just add some extra blank pages here. So let's go back here. The problem 4 is the function is 2x plus 3 over x. So problem 4, the function is 2x plus 3 over x. 2x plus 3 over x. 2x plus 3 over x. We want to find out the derivative first, and we can find the derivative by using this limit definition. This is just a simplification and finding the limit. Okay, so if you plug the value of f of x plus h, So this is the expression you are going to get. Let me do it here. Fx plus h is 2 times x plus h plus 3 over x plus h. F of x is 2x, and because of this negative sign, this positive becomes negative 3 over x over h. One more time, we just would like to simplify on the top part, and the ultimate goal is to factor out h from the top and cancel out this h from the bottom. Okay, so let's simplify this top part. So this is limit h equals to 0. Distribute this 2, which is 2x plus 2h. You cannot do anything here, which is 3 over x plus h. Negative 2x, negative 3 over x. So over h. You can cancel this negative 2x and this positive 2x. Now, to simplify further, you have to make the same denominator here. So you have to take the LCD, least common denominator. So that would be x times x plus h on the top part. So let's do that. So let's make everything 2h times h x times x plus h plus 3 times x minus 3 times x plus h. So to make same denominator, which is least common denominator, LCD, we have to multiply this first term by x times x plus h. We have to multiply this second term by x, and this third term by x plus h. So eventually, on the top part, this is what you can see, and on the bottom part, you will see x times x plus h. And there is a h on the denominator, so that h also goes here. Okay, so now just simplify on the top part. So after simplification, this is what you are going to get. Just distribute this 2xh here, distribute this 3 here, cancel out the opposite term, and the leftover would be on the top part after combining the like terms and canceling the same unlike terms. Unlike meaning one is positive, another one is negative. This is what you are going to get on the top part. So as you can see that on the top part there is a h, there is a h, there is a h, so you can just factor out h and cancel with the h on the denominator. And finally, after that, you can now able to put h equal to 0 here, and that will give you 2x minus 3. So that is 2x minus 3, and remember there is x times x plus h as well on the bottom part. So 2x minus, there will be after cancellation, let me go back to x squared, 2x squared minus 3 on the top part, and on the bottom part there will be x squared, because you put h equal to 0 here, and then the only leftover will be x times x. This h will be cancelled out. So this is, if you just simplify this, if you just if you just split these two into two parts, it will be 2 minus 3 over x squared. So that's the derivative of the function we have given. That's a general derivative. But in this problem, we want to find out the derivative when x is negative 5. That means we want to put x equal to negative 5 in the given. The derivative is 2 minus 3 over x squared. That's the first part of the answer. And for the second part, you have to find out the value of this thing when x is negative 5. So that would be 2 minus 3 over 5 squared, which is 25. If you simplify this, it will be 47 over 25. So that's the second part of the answer for problem number 4. So let's go back to problem 4 one more time. The first part asks you to find out the derivative. We found the derivative is 2 minus 3 over x squared, and the value of this derivative when x is negative 5, that's the slope. which is 47/25. Okay, we have to use the very same idea for problem 5. Problem 5, use the formula, this formula. So just need to find out the limit for this function. Okay, so let me just use once again, the extra page here. So problem 5, the function is, for the problem 5, let me go back and look at the function. Function is 3 over x plus 9, and the derivative can be found by using this formula, f of z minus f of x over z minus x. Remember one more time, it's not possible to find out this limit without simplifying this g minus x from the denominator. So the idea is, here in this case, you have to plug the value of f of z, f of x, simplify on the top part, and cancel out this g minus x from the simplification. That's the only way we can go further. Okay, so as you can see, f of x is 3 over x plus 9. So from here we can find out f of z is 3 over z plus 9, and f of x is 3 over x plus 9. We're going to plug this value back in this limit here. So it would be 3 over x plus 9 minus 3 over, sorry, it should be g plus 9 over minus 3 over x plus 9. And we already have z minus x on the denominator. Let me just change the color here. So now you just have to simplify on the top part. You can see that there is a z plus 9 for the first denominator, and there is x plus 9 for the second denominator. To simplify this, you have to make the same denominator, which is LCD. So to do that, you have to multiply the first term by x plus 9 on the top and on the bottom. And for the second term, you have to multiply by z plus 9. So in that way, you will have the same LCD. By doing that, so on the top part, you will have 3 times x plus 9 minus 3 times z plus 9, and for the denominator, that will be z plus 9 times x plus 9. And as you can see that this z minus x from the denominator, that will be also here z minus x. So now ultimately you have to simplify this top part, and you need to find out g minus x on the top part so that you can cancel this g minus x, because as long as this g minus x is on the denominator, you will not be able to find the limit. Okay, but it's just not that difficult. Just distribute this 3x plus 27 minus 3z minus 27 over z plus 9 times x plus 9 times z minus x. This negative 27, this positive 27 is gone. Remember, we want z minus x on the denominator, but there is a 3x minus 3z. So just factor out negative 3. In that way, if we factor out negative 3, we can rewrite this top part as a z minus x, because there is a negative sign here. So now on the bottom part, there is already z minus x. That's the whole point. We can cancel out this z minus x and this z minus x on the top part. So finally, now we can find out this limit by plugging g equal to x. So negative 3 over x plus 9 times x plus 9, which is x plus 9 squared. So that's the derivative of the function by using this limit. Okay, that's problem 5. For problem 6, you can see graph the derivative of the function graphed on the right. So this is the graph of the function, and we would like to find out, which one represents, out of this four, which one represents the graph of the derivative of the function. So let's focus on this graph of the function here. So as you can see that at 0, let me just collect the information. At 0, to find out the derivative of this curve, if you draw the tangent line here, you can see that it would be horizontal tangent line. So at 0, the derivative would be 0. On the left side of the 0, at any point, if you try to draw the tangent line, you can see that the slope of that tangent line would be positive. And on the right side of this, 0, at any point, if you try to draw a tangent line, the slope of that tangent line would be negative. So that means the derivative for this graph, we can just see that the derivative on the left side of 0 would be positive, the derivative on the right side of the 0 would be negative, and the derivative at 0 is 0 itself. So here it's positive, here it's 0, and here it's negative. So we need to find out the graph, one of this graph, which is positive on the left side of the origin, which is 0 at origin, and which is negative on the right side of the origin. Look at the first graph. It is negative, so this is not the right one. It is negative on the left side. Look at the second one. This is positive on the left side of the origin, 0 at 0, and negative on the right side. So this is the possible one. And rest of the C and D, they are not possible one, because you can see that on the left side there are both positive and negative values, which is not possible. There are both positive and negative values. So the only possible answer is this one. Okay? So that's how we find out the graph for the derivative of this given function. So the answer is B. Let's go to next problem, problem 7. We need to find out the derivative by using the product rule, and another way is just multiply, distribute that, and find the derivative. Okay, so let me do this number 7 here. If you have y equal one function times another function, by using the product rule, the derivative of this kind of function is the derivative of first function times the second one plus first function times the derivative of the second one. So here in this problem, the first function f is 7 minus x squared, and the second function z is x cubed minus 2x plus 1. So now I'm going to use power rule for finding the derivative of f. The derivative of 7 is 0, the derivative of x squared is 2x, so it will be negative 2x. The derivative of x cubed is 3 times x squared. By using the power rule, x minus the derivative of 2x is 2. I'm going to plug this value f, z, f prime, and g prime here, and we can find out the derivative. Okay, so here the derivative y prime equal f prime, which is negative 2x, times g, which is x cubed minus 2x plus 1, plus f, which is 7 minus x squared, times g prime, which is 3x squared minus 2. Now for finding the answer, you just have to simplify this expression here. So let's continue. For problem 7, if you just distribute this negative 2x here, so it will be negative 2 times x to the power 4, positive 4x squared, negative 2x. And let's do the very same thing here. If you just distribute 7 and then after that negative x squared, it will be positive 21x squared, negative 14, negative 3x to the power 4, positive 2x squared. And if you just simplify further here, you are going to get negative 5x to the power 4, positive 27x squared, negative 2x, negative 40. And that is by using the product rule. Now for this same problem here, you also have to find out the derivative by multiplying this thing first without using the product rule. I'm going to leave this for you. Just distribute this 7 and x square and just use the general power rule. Finally, you are going to get the same derivative. So this is for you to do, the second part. For problem number 8, you can see that y equals 7x minus 8 over 8x plus 7. We can use a quotient rule for finding the derivative of y. So problem number 8, y equal f over z. In this case, we can find out the derivative by using the quotient rule, which is derivative of the function on the top times the function on the bottom minus function on the top times the derivative of the function on the bottom divided by square of the function on the bottom. This is called quotient rule. In our case, f is that's problem 8, 7x minus 8, that is our f, and z is 8x plus 7. So we can find out f prime, which is 7, and g prime, which is 8, and we're going to use this value back here in this formula, and eventually we're going to get, after using this value back in this formula, y prime would be 7 times 8x plus 7 minus 8 times 7x minus 8 over that is 8x plus 7 squared. So on the top, if you simplify, after simplification, as you can see that 7 times 8 is 56, 8 times 7 is negative 56. So the first term will be cancelled out. So after that, you have to add 7 times 7, which is 49. Negative times negative is positive 64. Eventually, that will be 113. And on the denominator, it is 8x plus 7 squared. So that's the derivative by using the quotient rule. That's problem 8. Okay, let's go to problem 9. A body moves on a coordinate line such that it has a position. This is the position function for an object on the interval from time t is greater or equal to 1 to less or equal to 4. We need to find the displacement and average velocity. We need to find the speed and acceleration, and we need to find out if there is, when, if ever, during the interval does the body changes the direction. So let's try to do this problem 9. I'm going to insert one blank page here one more time. Problem 9. So let's go to problem 9. For the first part, A, remember the position function we have given is s of t. It is given 16. Let me use that. It's 16t square, 16 over t square minus 4 over t. 16 over t square minus 4 over t. The interval is given from 1 to 4. So for the first part, we need to find out the displacement. Displacement when the body moves from 1 to 4. Displacement can be found by finding the position at 4 minus the position at 1. So just need to find out the value of this position function at 4 and 1. If you do that, it will be just plug t equal to 4 here, which is 16 over 4 square minus 4 over 4 minus t equal to 1 here, which is 16 plus 4. I am writing here plus because of this negative sign. This negative becomes plus. If you simplify this thing, you are going to get negative 12. So that is the displacement from time, when body moves from time 1 to 4. Okay, so that's the displacement. And now we know the velocity. Its velocity is displacement you know, displacement over time, and we need to find out here, as you can go here, find the displacement and average velocity. So average velocity can be found. Average velocity is displacement over total time. So in this case, the displacement from when body moves from time 1 to time 4, 1 second to 4 seconds, the displacement is negative 12, and time is total time it takes is 4 minus 1, which is 3. So the velocity would be negative 4. Okay, so for that is for part A. For part B, it says find out the speed and acceleration. Don't forget that speed means it's the absolute value of the velocity. So speed means it's absolute value of the velocity, and this is average velocity. This is average velocity. We are looking for general velocity. Velocity means it's actually rate of change of position, which is actually the derivative of the position function. So we can find the velocity by finding the derivative of s of t here with respect to time. So the derivative of the function we have given, which is 16 over t square minus 4 over t, just use the general power rule. As you can see, this t square can be, we can take this to the numerator and we can write this as a t to the power negative 2. So while finding the derivative, look at here. 16 over t square can be written as 16 times t to the power negative 2. And when we find the derivative of this thing, this negative 2 comes in front, so it will be negative 32 t to the power negative 3. So I'm going to use that fact here, negative 32 over t cube for the first expression. For the second one, it will be positive 4 over t square. So that is our velocity. Okay, and now acceleration means the derivative of the velocity, but in our problem we are asked to find out the speed at the endpoints. So speed means its absolute value of this thing at the endpoint mean when time is 1 and time is 4. So let's find out the velocity. Let's write down the velocity as v of t. So the velocity at when time is 1 is this block t equal to 1 here. It would be negative 32 plus 4, which is negative 28. So now the speed when time is 1, speed would be absolute value of negative 28, which is positive 28 when time is 1. When time t is 4, the velocity would be negative 1/4. Just plot t equal to 4 here and just simplify. That will give us the speed equal to positive of this value, which is 1/4. So speed at the end point is 28 and 1/4. We have to do the same thing, and we need to find out the acceleration at the end point. Acceleration means the derivative of the velocity. So we need to go one step further here. So let's say a of t is the derivative of the velocity, which is the acceleration, and the derivative of this would be let me find out the derivative. It would be 96 over t to the power 4. I'm using the very same idea, general power rule, and we need to find out the acceleration when time is 1. That will be 88. Just put t equal to 1 here, and the acceleration when time is 4, and that will be 1/4. So these are the answer for the acceleration, and these are the answer for the speed. So that's a part B. We still have part C. In part C, we need to find out either that object changes the direction or not. So direction depends on the velocity. If you can see the velocity, let me just add one more place here. So velocity gives you the direction of the object. Velocity gives you the direction of the object. Velocity might be positive, might be negative, and velocity is 0. This is the point which tells us either the object changes the direction or not. Okay, so in this problem we just have to find out, is there any time from t equal 1 to 4, is there at some point in this interval can we find out the velocity which is 0? If that is the case, then we can say that yes, that body will change its direction. So let's solve this equation when the velocity would be 0. Remember, if you go back and check, the velocity is negative 32 over t cubed plus 4 over t squared. Now we just have to solve that. Negative 32 over t cubed plus, let me go back one more time, 4 over t squared. Let's check and try to solve this equation. If you try to solve this equation, we have to make the same denominator. So there is a t cube, there is a t squared, so I'm going to multiply this by t, and eventually that would be 32 plus 4t equals 0. We can just multiply both sides by t cube, and that will give us t equal 32 divided by 4, which is 8. So the only time that when the velocity would be 0 is when time is 8 seconds. But that is out of this interval. We are just caring about time from 1 to 4. So there is no way this velocity would be 0. That means there is no way the velocity would go from negative to positive or positive to negative. That means the object is not going to change the direction. So the answer for this part is no. No, the object, the body, it's not going to change the direction. So Vt is not 0 on this interval. So it means body does not change the direction. That's problem 9. And let's go to now problem 10. So let's go to problem 10. The equation for free fall at the surface of celestial body in outer space. So this is the equation of free fall. How long does it take a rock falling from rest to reach a velocity of 27.8? So this is the position of position function, and we need to find out the how long does it take, so the time when the velocity is 27.8. So one more time we're going to use the same idea. Velocity means the derivative of the position function. We find the derivative of this function, and we equate that velocity 27.8 and solve for the time. Okay, so let's check. This position function is 9.44 t squared. So here I'm going to add one more piece. Where is that? Okay, so this is for problem 10. Problem 10, position function is given, which is 9.44 t squared. 9.44 t squared. So that means velocity we can find. Let's say v of t is the derivative of this function. If you find the derivative by using the power rule, it's 9.44 times 2t, which is 18 times 8t. So we need to find out how long does it take, when this the velocity would be it's 27.8 meter per second. So how long does it take a rock falling from rest to reach a velocity this one? So we need to find out the time when the velocity is 27.8. So find the value of the time when velocity is 27.8. So that means this 18.88 t, which is the velocity, is 27.8. Now you just have to solve for t. So just divide both sides by 18.88. So time would be 1.4725, 1.4725. But in this problem, we're asked to approximate this value to, you can see that, round to the nearest tenth as needed. So it would be 1.5 second. Okay, so that's problem 10. Let's go to next problem, which is problem 11. This is the graph we have given. This is the graph for the velocity function. This is the velocity. This is the graph for the velocity, so that means it's the derivative. And now we want to find out some of the information by using this graph. The first one is, when does the body reverse direction? So remember, if the velocity is 0, so it should go from positive to negative or negative to positive. That means when the body would reverse the direction. So look at this graph and find out the time when the velocity is 0. So you don't have to worry about the starting time, because we don't consider, it's changing the direction, because before the starting time there is nothing happening, so you don't have to consider 0. But other than 0, you can see that at t equal 5 and t equals 7, the velocity is 0, and it's going from positive to negative and negative to positive. So that means, the meaning is, it's changing the direction. So as for the answer for the A, the body reverses direction at time t equal 5 and 7. So these are the two answers for the first one. So now the second question is, when is it moving at a constant speed? That is the part B. The constant speed means the velocity should be, as you can see that, it should be, the derivative should be 0. So as you can see here, this is the derivative function, and this function is constant when time is from 1 to 4. From 1 to 4, this graph, as you can see that, this is the constant function. If you try to find out the slope here, the slope is 0. So from 1 to 4, from here to here, this is the, this graph is a constant graph. So the slope is constant. That means the body is moving at constant speed. Okay, so from t equal 1 to 4, the body is moving at constant speed. Here it's increasing, here it's constant, here it's decreasing, again increasing, again decreasing. So the constant is from this point to this point, from 1 to 4. So we're done with part A, B. Let's go to part C, graph the body's speed. So remember, speed means it's just a positive velocity. So wherever it's positive, you just have to copy and paste. If it's negative, just make it positive. So as you can see that, this is positive up to 5. From 5 to 7, it's negative. So just make it positive. So whatever you see, just flip it. If you flip it, the graph would come here. This flip would be like this. Okay, so the only part you have to change is this part. Instead of negative, you have to make it positive. So just look at the given graph here. Find out, very similar graph, except this negative part becomes positive. So this is completely different graph. It looks, this is completely different graph. It has still negative part. So these three are not the answer. The answer is this one. Everything else is same, except this from 5 to 7, this negative becomes positive, because the speed means positive. Finally, graph the acceleration. So acceleration means, one more time, don't forget that, it's a derivative of this this function velocity. So the slope of this graph. So as you can see, from 0 to 1 the slope is positive, from 1 to 4 the slope is 0, from 4 to 6 the slope is negative because it's going down, from 6 to 8 the slope is positive, and from 8 to 10 again the graph is going down, so slope would be negative. So use that fact, the slope should be positive, 0, and one more time negative, and then positive, and then negative. So look at the given graph here. We have positive, positive, positive. So this is not the right graph. Positive, 0, negative, positive, and one more time negative. So the only option we have is this graph is not right because it's positive, 0, and again positive, but that's not the case. We have, it should be, don't forget that, from 0 to 1 it should be positive, from 1 to 4, so let me just draw here, from 0 to 1 it should be positive, from 1 to 4 it should be 0, from 4 to 6 it should be negative, from 6 to 8 it should be one more time positive, and from 8 to 10 it should be negative. So you just have to find out a graph which satisfies this all property, and there is only one graph, which is this one, which satisfies all the property. So that is the graph of acceleration. So don't forget that acceleration means it's a derivative of the velocity. Let's go to the next problem. Problem 12, find the derivative of y equal x squared times sine x plus 2x times cosine x minus 2 sine x. Keep in mind, the derivative of sine x is cosine x. This prime means derivative. The derivative of cosine x is negative sine x. And the another thing is you have to use the product rule here. So by using the product rule for the first part and then second part, by using this derivative information, you will be able to find the derivative here. So let me find out the derivative y prime. If I use the product rule, I'm going to find out the derivative of x squared, which is 2x, multiply it by sine x, plus I'm going to leave x squared as it is, and I'm going to find the derivative of sine x, which is cosine of x. So the first part is done. So there will be two parts here for the first one because of product rule. I have to do the same thing for the second part here. I need to use the product rule here. So derivative of x is 1, so 2 times cosine of x, and next time I'm just going to keep 2x, and derivative of cosine x is negative sine x, so I already made it negative, so that is also done for the second part. Finally, derivative of sine x is cosine of x. If I simplify here, you can see that there is a positive 2x and there is a negative 2x. We can cancel this out. There is a 2x times sine x, there is a negative 2x times sine x. It will be cancelled out. So eventually, the only leftover thing would be x squared times cosine of x. So that's the derivative of this function, x squared times cosine of x. Okay, let's go to next problem, problem 13. To do this problem, keep in mind, if you have sine and there is a function of x and there is some limit outside, limit x approaches to some value a, if this function f of x is defined at a, you can always bring this limit inside. That's the property of sine function for the for the function which is defined at a. So we can use the same approach here. We can just bring this limit inside because this function 5 pi over x is defined when x is 3, and when x is 3 this function becomes 5 pi over 3, and if you subtract 5 pi over 3 minus 2 pi over 3, that will give you 3 pi over 3, which is eventually pi, so sine pi would be 0, okay, by using this fact. So this will be, I'm going to change the color here so that you can see the difference. Let me just use red one. So this will be sine limit of this function, which is 5 pi over 3 minus 2 pi over 3. I put 3 here because x is approaching to 3 and that is defined. So 5 pi over 3 minus 2 pi over 3 is eventually it's pi. So sine pi is 0. So that's the answer. For problem 14, this is the composition of two functions. So one function we can assume of 5x minus 9. Another function we can assume, u to the power 7. So here we have asked what is the f of u and what is the u or g of x. So always choose the g of x with the function inside the parentheses. By doing that, we can assume g of x equal 5x minus 9 and f of u, which is we can assume because there is a 7, the power u to the power 7. Don't forget that u means g of x, so it's basically g of x to the power 7. So that option we have given here at B, so this is the right option. Now for finding the derivative of this kind of function, I'm going to give you a very simple formula here. If you are looking for the derivative of f of x to the power n, derivative of this function is just n times f of x to the power n minus 1 times f prime of x. Fx means this function inside this bracket. So by using this fact here, the derivative of this function is 7 times 5x minus 9 to the power 7 minus 1, which is 6, times the derivative of the function inside the parentheses, which is 5. So eventually it will be 7 times 5x minus 9 to the power 6 times 5. This 5 is the derivative of this 5x minus 9 by using this fact. Now, if I just multiply 5 and 7, it would be 35 times 5x minus 9 to the power 6. Okay, I did a mistake here. It should be here, okay? It should be here. So that is 35 times 5x minus 9 to the power 6. And okay, I have to cancel this one. Okay, so for next problem, problem 15, find out the derivative of this function, which is basically it's a 1 over cosecant of x plus cotangent of x. When finding the derivative of this function, we have to keep in mind, we have to know the derivative of, I'm going to add, one extra page here for problem 15. Let's see problem 15. Y equal 1 over cosecant of x plus cotangent of x. I'm going to give you some of the formula. The derivative of cosecant of x is actually a negative cotangent of x times cosecant of x. Derivative of cotangent of x is equal to negative cosecant of x squared. So these are the two, derivative we are going to use here for finding the derivative of y. We have to use the quotient rule. So y prime is derivative of 1, which is 0, minus derivative of this part, meaning derivative of the first part, which is derivative of cosecant of x, so which is negative cotangent of x times cosecant of x, plus derivative of cotangent of x, which is negative cosecant of square x. So that negative makes this plus minus over the square of this function. So remember what I did is I use the quotient formula. So the function on the top is 1 and then function on the bottom is this whole thing. And I found the derivative of 1 is 0. So 0 times this function on the denominator is 0. I don't have to write it down. Minus, it's coming from the formula. The function on the top is 1 times the derivative of the function on the denominator. So we need to use the derivative for the cosecant of x, which is negative cotangent of x times cosecant of x. That's what I use here. Plus the derivative of cotangent of x, but the derivative of cotangent of x is negative cosecant square x, so that's why it's negative. Because there is a negative here, so this becomes positive, and I can factor out cosecant of x from the top part, and then leftover would be cotangent of x plus cosecant of x. But on the bottom also we have cosecant of x plus cotangent of x squared. So you can see that the top part and one of the bottom part, they are same, so we can cancel out. So the leftover will be cosecant of x over cosecant of x plus cotangent of x. So that's the derivative of the function for the problem 15. Okay, so let's go to the next problem, problem 16. And problem 16 is find the derivative of this. For finding the derivative of this function, we can again use the same formula like we did for problem 14. If there is a function to the power n, the derivative of that kind of function is n times the function to the power n minus 1 times the function inside the bracket. So in this case, the function inside the bracket is 2 plus 3 over x. So, but keep in mind, we need to find out the derivative of the derivative, so that there is a double prime. So the first derivative would be y prime would be 3 times 2 plus 3 over x to the power 2 times the derivative of function inside the parenthesis here, which is negative 3 over x squared. Okay, and that's y prime only. We need to find out the second derivative. So when finding the second derivative, we have to use the product rule. Okay, so I'm going to use, the next page here, 16. Y is so y prime we found is 3 times 2 plus 3 over x squared times negative 3 over x squared, which is basically negative 9 over x squared times 2 plus 3 over x squared. So y double prime means here we need to use the product rule. So find the derivative of the first one, which is negative 9. So the derivative of 1 over x squared is negative 2 times 1 over x cubed. The negative from here and the already negative, this negative becomes positive. So 2 over x cubed. That's the derivative of 1 over x squared. You just have to keep 2 plus 3 over x as it is, because we are trying to use the product rule here. So I found the derivative for the first part. I just kept the second part as it is. Now plus, but because there is a minus already, so minus, I will just keep this first part as it is and find the derivative of the second part, which is 2 times, one more time, it's a general power rule, 2 plus 3 over x, 2 minus 1 times the derivative of the function inside the parentheses, which is one more time, it's a negative 3 over x squared. Okay, if we try to simplify here, we can see that this is 18 over x cubed, 2 plus 3 over x squared. This is, there is a negative becomes positive. 9 times 2 is 18 over x squared is x cubed, 2 3 over x. I'm just rewriting this as 18 over x cubed because I would like to just factor out this 18 over x cubed times 2 plus 3 over x. I'm just trying to simplify this term. Okay, and now we can factor out 18 over x cubed times 2 plus 3 over x from both of them, and can write down the leftover thing. From the first one it is 2 plus 3 over x, and from the second one the only leftover will be 3 over x. So eventually it's 18 over x cubed times 2 plus 3 over x. If you add this 3 over x and 3 over x, that will give you 6 over x. So that's the second derivative of the function we have given for problem 16. For problem 17, we have to use the implicit differentiation here. So remember, for the implicit differentiation, if there is a y to the power something, the derivative of y to the power something is, y to the power n. The derivative of this kind of thing is n times y to the power n minus 1 times dy over dx. That's what we have to use for the implicit differentiation. So by using that fact, if we differentiate both sides, we need to use the product rule for the first term. So we need to find out the derivative of x squared, which is 2 times x. So there is a 3 already, so it would be 6 times x. Why? Because we have to use the product rule for the second time, it's 3x squared times dy over dx. And we can do the same thing for the second part, 7y squared, because the derivative of x is 1, plus 7 times x times 2y. So eventually it becomes 14xy dy over dx. And that is the case on the left side. On the right side, because there is a negative 3, the derivative will be 0. So finally, for the implicit differentiation, if you are finding the value of dy over dx, you just keep all the terms with dy over dx on the left side and rest of the thing on the right side. Okay? So here in this case, okay, so let me just use a different color here. So we have to bring this 6xy on the right side, 7y squared on the right side, and we have to factor out dy over dx, and negative 6xy, negative 7y squared divided by, after factoring, after factor out dy over dx from these two terms, the leftover would be 3x squared plus 14xy. So we have to divide both sides by 3x squared plus 14xy. And that's how we can find out dy over dx. That's problem 17. Let's go to problem 18. This is very similar kind of problem because it's implicit differentiation. So if we try to find out the derivative on the both sides, the derivative would be 4 times 2x, which is 8x, plus 2y times dy over dx equals 0. And if we try to solve for dy over dx, it will be negative 8x over 2y. And if you simplify this, it will be negative 4x over y. So just try to find out where dy over dx is negative 4x over y. So this is the right option we have available. Now, after finding that, we have to find out the second derivative. So there are two ways to do it. You can, continue this equation and just differentiate both sides one more time, or you can just use this one, find out the second derivative, use the quotient rule, and plug the value of dy over dx. I'm going to use this first part. I'm going to differentiate again. Differentiate this first part, so it will be 8 plus, and now you have to treat this y and dy over dx as a two different function. So you have to use the product rule. So first, I'm going to find out the derivative for y, which is dy over dx, and there is already dy over dx, plus 2 times y, and derivative of dy over dx is actually d squared y over dx squared, which is second derivative. And on the right side, it's already 0. Now for finding this value, you have to bring everything on the right side, and you also have to plug the value of dy over dx from the first part, which is negative 4x over y. So if I do that, if I try to simplify this, d square y over dx square. This is what I'm going to get. I have to bring this 8 to the right side, and this negative 2 times dy over dx, so square of dy over dx. But we know that dy over dx is negative 4x over y, so that is what we're going to plug over divide by 2y. So now you just have to simplify this. There is a 2 factor in 8, there is a 2 already, and there is a 2 here, so you can cancel out that 2. So eventually it will be negative 4. This negative 4 times 4 is 16 x squared over y squared divided by 2y. Now try to simplify this and look at the the value. So you can see that if you factor out negative, it will be 4y squared plus 16x squared on the top, and on the bottom it will be 2 times y cubed. So negative 4y squared plus 16x squared over y cubed is our answer for the second derivative, and that's given here. Okay, so that's problem 18. For problem 19, we're going to do the same thing, implicit differentiation, but finally after finding dy over dx, you have to put the value of x and y, which is 3 and 1. 3 and 1, it's given. So this is the equation we have given, and we want to find out the equation of tangent line at point 3,1. So remember, for finding the equation of tangent line, you have to find the slope, which is basically dy over dx. So I'm going to add one extra place here to do this problem 19. Problem 19. So for problem 19, x squared plus xy minus y squared. So let me use from here, problem 19. X squared plus xy minus y squared equal 11. So this is the curve, and we want to find the equation of the tangent line to this curve at point at 3, 1. So we have to find out the slope. Slope means dy over dx, so that means you have to differentiate, find the derivative both sides, and implicit differentiation. So it will be 2x plus y. The derivative, I'm going to use the product rule here. So derivative of x is 1, so 1 times y is y. And now x times dy over dx minus 2 times y times dy over dx equals 0. So our goal is to find the dy over dx. So we just bring this 2x plus y to the right side. Factor out dy over dx. If we factor out dy over dx, the leftover will be x minus 2y. And on the right side, it's negative 2x, negative y. So dy over dx would be negative 2x minus y over x minus 2y. But remember, slope at 3, 1, meaning the value of this dy over dx when x is 3 and y is 1. So 2 times 3 minus 1, it's a 3 minus 2 times 1. If you simplify this, it will be negative 7 on the top and 1 on the bottom. So eventually it will be negative 7. So that's the slope at 3, 1. So now for the part A, for the equation of tangent line, it's y minus y1, which is 1, time equals slope, which is negative 7, x minus x1, which is 3. So that is y minus 1 equal negative 7x positive 21. So after adding 1, y is negative 7x positive 22. So that's the equation of tangent line at 3, 1. For part B, give the equation of the line that is normal to the curve at that point. So the slope of the line which is normal can be found by flipping this slope of the tangent line. So for the part B, slope would be negative 1 over slope of the tangent line. So that's the slope of the normal line. Okay, so slope at 3, 1. So let's say this is m, and slope of the normal line will be negative of 1 over m. So if we plug the value of m, which is already negative 7, so it will be eventually the slope of the tangent line will be 1 over 7. Here is the thing I'm going to give you. This is the graph, and let's say at point 3, 11, this is tangent line at 3 and comma 11. Okay, let's go up here. So it's a 3 and 1. Sorry, it's not 11. Okay, 3 and 1. So I'm going to just erase that. It should be 1. So at 3, 1, this is the tangent line. So now the normal means it's the line which is just perpendicular to this tangent line. So if m is the slope of the tangent line, negative 1 over m would be the slope of the normal line. Okay, so by using that fact we can find out the slope, which is 1 over 7, and now the equation of normal line would be y minus y1, which is 1, slope x minus x1, which is 3, and y minus 1 equal x over 7, negative 3 over 7. And if we just add 1, negative 3 over 7, positive 1, that will give you 4 over 7. So y equal x over 7, positive 4 over 7. So that's the equation of normal line. That's problem 19. Let's go to problem 20. Assume that x is the function of time and y is also a function of time. Means here in this case it's a t, it might be time. So now here we have given the relation between y and x, and we also have given the derivative of x with respect to t when x is 3. Now we need to find out the derivative of y with respect to t. Okay, so let me add one more place here. So don't forget that y is equal to x squared plus 7, and the derivative of x with respect to t is 2 when x is 3. So y equal to x squared plus 7. This is problem 20. Y equal to x squared plus 7. Derivative of x with respect to 2 is it's 2. Derivative of x with respect to t is 2 when x is 3. So we need to find out the dy over dt. So just differentiate this equation. Differentiate means find the derivative with respect to t. With respect to t. So it will be dy over dt equal 2x times dx over dt. So now we need to find out what is dy over dt when dx over dt is 2 and x is 3. So just plug the value of x is 3 and dx over dt is 2. So it will be 12. Okay, that's problem 20. Let's go to problem 21. Okay, we have given the volume in terms of x and y. V equal 12x squared times y. And how is dv over dt related to dy over dt? So just find out the derivative of v with respect to t. If x is constant, so just keep that 12x squared is constant. So if that is the case, then dv over dt, because this 12x squared is constant, we just keep that outside, and y is the function of t, so dv over dt would be 12 times x squared times dy over dt. So this is 12x squared. By using the very same fact, if you try to find out, if you just keep y as a constant and try to take x as a function of t, then derivative would be 12 times y times 2x times dx over dt. So 12 times y times 2 x times dx over dt. So because x square, the derivative of x square is 2x times dx over dt. So finally it will be 12 times 2 is 24xy dx over dt. So now if we think, x and y both are function of t, then we have to use the product rule, and dv over dt would be, first find out the derivative of x with respect to t. By doing that, it will be 24xy dx over dt, plus second, because we're using the product rule, now we need to find out the derivative of y. So 12x squared times dy over dt. So this is 24xy and this is 12x squared. That's problem 21. So for problem 24, this is the word problem, so you have to read this question very carefully. A 25-feet ladder is leaning against a house when its base starts to slide away. By the time the base is 7 feet from the house, so the base is moving away at the rate of 48 feet per second. So we have to answer this question: what is the rate of change of the height of the top of the ladder, and what rate is the area of the triangle formed by the ladder wall and the ground changing there? I'm going to add one extra page here. Problem 22. Problem 22. There is a house, and so let's say there is a ladder. Okay, so the ladder is 25 feet, it's given, and this angle is given theta. So let's say this distance of this ladder from the house, this is house, is x. So that distance depends on the time, so it's a function of time. This height of the ladder is y, which is function of time one more time. So now let's go back to the problem and read it one more time. The ladder is 25 feet, and now we have given that when this ladder is 7 feet away from the house, so that means when this x is 7, the rate of change of this distance x is 48 feet per second. So these are the information we have given. When x is 7, the derivative of x with respect to time is 48 feet per second. When this thing happens, we need to find out rate of change of y. Okay, so we need to find out, that's the first question, what is the rate of change of the height of the top of the ladder? So this is y. So we need to find out the rate of change of y. For finding this information, we need to use the geometry here, this graph here, for finding the relation between x, y, and this 25, if there is any relation. By looking at this picture, you can see that this is a right angle triangle, so we can use the Pythagorean theorem here. And according to Pythagorean theorem, x squared plus y squared would be 25 squared. Okay, so now if we differentiate both sides, differentiate with respect to time, both sides, the first thing would be 2x dx over dt plus 2y dy over dt, and then right side would be 0. Since we are looking for dy over dt, so just simplify that. So just bring this thing to the right side and divide it by 2y. That will give you dy over dt equal negative 2x over 2y dx over dt. So we can cancel this 2 and 2. So for finding the rate of change of y with respect to time, we need to put the value of x, value of dx over dt, and value of y. We know the value of x is 7, dx over dt is 48, but we don't know the value of y, but we know this relation. So let's find out what happens when x is 7, what happens to the y. Y would be 25 square minus x square. So y square is 25 square minus 7 square. So y would be square root of 625 minus 49, which is, what is that? Um, Let me find that. 625 minus 49 and square root of that number. So 625 minus 49, that's 576, and the square root of that number is 24. So when x is 7, the y would be 24. So just plug that value here. Negative 7 over 24 times dx over dt is that is 48. So 24 times 48 is 2, so that is negative 14 feet per second. The meaning of this negative is the height is going down. Height of that slide, the ladder is going down. It's going down. That's why it should be negative. Okay, so that's negative. That's negative 40. Negative 40. So for the first part, and for the second part, let's go to the second part. Part B. What is at what rate is the area of the triangle formed by the ladder, wall, and ground changing them? So first of all, find out the area in terms of x and y, and we know the area is for part B, area equal half times x times y. We want to find out the rate of change of area with respect to time, so we have to use the product rule here, and that would be the derivative of x with respect to t, because that's both of them are function of time, so we have to use the product rule plus x times derivative of y with respect to time. I'm going to add one more base here. So let's keep continue now. Okay, so this is the rate of change of area would be can be found by plugging this value. Dx over dt is 48 times 24, x is 7, and dy over dt is negative 14. That's why I already made it negative. If you just do the math here, it would be 527 feet square per second. Don't forget that it's a rate of change of area, so it's a feet per second square. Finally, part C, we need to find out the rate of change of angle. The angle is changing, so we need to find out the relation between angle and x and y. So as you can see that tan theta is equal to y over x. So we can use that fact here for finding the rate of change of theta. So see from the picture, tan theta is y over x. So now for finding the rate of change of theta, differentiate both sides with respect to t. Differentiate with respect to t, both sides. If we do that, so or maybe I can use sine theta and cosine theta. So here this is the picture, this is theta, this is y, this is x. Let me use sine and cosine here. What is that? You can also use this one, but I have to use the quotient rule, and I don't want to use the quotient rule, so I'm just changing it to in terms of sine and cosine. Okay, so by looking the picture here, I can say sine theta is b over h, so it's sin theta is p over h, it's a y over 25. Don't forget that this is 25. So if I differentiate both sides with respect to time, on the left side the derivative of sin theta with respect to theta times j theta over dt by using the implicit differentiation, that would be cosine theta times j theta over dt, and that is 1 over 25 dy over dt. So now for finding d theta over dt, we have to use the value of cosine theta, and from this picture we can see that cosine theta is base over hypotenuse, so x over 25. Okay, so I'm going to use that fact here, and d theta over dt equal 1 over 25 cosine theta, which is x over 25 cosine theta dy over dt. So this cosine theta is x over 25 dy over dt. So this 25 and this 25 is gone. So rate of change of the angle at that moment is, you have to put the value of x and dy over dt. So the value of x is 7 and dy over dt is negative 14. So eventually it's negative 2 radian per second. Don't forget that it's angle, rate of change of angle, so it should be radian per second. Okay, so that's problem 22. Okay, so for 23 it's a linearization problem. Okay, let me just add one more place here. This is the linearization problem. So I'm going to give you simple, review kind of thing for the linearization here. Let's say you have a curve like this, and sometimes this curve or this function we're dealing here, for finding the value of this function at some point would be not easy, but we always know the relation between the curve or the function and the tangent line to that function at any point. So look at here, the value of the function at this point, let's say at a, the value of the function at a, the value of the function, let's say this is f of x, the value of the function at a and the value of this tangent line at a, they are same, right? Because the value, they are intersecting. So sometime for finding the value of the function at some point would be very difficult, but for finding the value of a line at the very same point would be very easy. So what happens is, linearization means we try to use the equation of this tangent line to approximate the value of the function at some point. That's called linearization. And so we use the equation of tangent line, which is basically y minus y1 equals slope times x minus x1. In this case, it's a comma fa. So this y1 would be f of a. Slope is the derivative of the function at a, x minus a. So the y is f of a plus f prime of a, x minus a. So this y, this value of this line, we just denote this by L of x, which is the linearization of the function. So we approximate the value of the function by using this linear equation L of x, this equation. Okay, and that's called linearization. So we can find out the value of this any function f of x at any point a by using the equation of this tangent line, and this is how we write down the equation of tangent line. So in this case, we have given here we have given a function is x squared plus 9x, and we would like to find out uh, find a linearization that will replace the function over an interval that includes the given point x0. Center each linearization not at x0 but at nearby integer x is equal to a. So here in our problem, x0 is 0.01, and to approximate the value of this function at 0.01, we have to choose something very close to x0, which is easy to find for L of x. So for this 0.01, we can pick the value of a is equal to 0 because it's very close to 0. So in this case, we say a is 0, and we try to linearize, try to use this linearization to approximate the value of the function at 0.01. Okay, so let's go and find out the value of the function we have given. The function is x squared plus 9x, and we want to use this linearization formula to approximate the value of the function at 0.01. Yes, you can find out the value of this function at 0.01, but this is just for understanding purpose. Okay, sometimes your function could be very difficult and it's not easy to find out at that point. So we can choose a equals 0 here, which is very close to that point 0.01. So by doing that, we can find out f of 0, which is 0. We can find out the derivative of the function, in this case is 2x plus 9, and the value of the derivative at 0 is 9. By using that fact, we can find out L of x, which is just plug f of 0, which is 0, plus f prime of 0, which is 9, times x minus 0. So linearization is 9x. Okay, so if we go here, the value of L of x, say the center of the linearization at x equal to 0, and linearization is 9x. So the answer for this 23 is 9x. Okay. Okay, so that's 23. Let's go to 24. It's just a implicit differentiation. You can just find out the derivative both sides and solve for dy over dx, and finally multiply both sides by dx, and you will be able to find out the dy. I'm not going to do this problem because it's exactly the same as the implicit differentiation. The answer for this problem would be A. Now for the last problem, that's 25. The radius of a circle is increased from 4.0 to 4.09. So there is a circle, and the radius of the circle at the beginning is 4, and we would like to increase the radius of that circle. Let me just use another one by slightly by 0.0, 0.09. So the radius of the new circle will be 4.09. So you can see that the radius is increased from 4 to 4.09. So now we can find out the area of the first circle very easily, and by using that first circle, area of the first circle, we would like to estimate the area of the second circle. One more time, you can find out the area exactly here for this particular problem, but we would like to know the process so that we can use that for the complicated problem as well. So first of all, to do this kind of problem, first of all you have to know the area for the circle, which is pi times r squared, and the rate of change of area, which is derivative of a with respect to radius, is pi times 2r times, with respect to radius is just 2r. So change in the area can be written as pi times 2r times change in the radius. So now the first part we have to estimate the change in area. So the estimation in change in area can be found by using this formula. So first of all, we have to know what is the change in radius. Okay, if you look at the problem here, you can see that the radius is changing from 4 to 4.09. So change in radius, the change in radius is 0.09. So for the first part, change in area can be found by pi times 2 times 4 times 0.09. This 4 is for the radius. If we use this information, then this would be 0.72 pi. So that's the change in area we can see, we can estimate if we change the radius by 0.09. For second part, we need to find out percentage change in the original area. So this is actually percentage change is equal to change in area over the area itself. So the change in area is 0.72 pi, and area of the original circle is pi times 4 squared, which is 16 pi. If we divide this by 0.72 pi by 16 pi, it would be 0.045, which is 4.5%. Okay, so that's problem 25. I hope you understood all the problem I explained here, and if you have any questions, feel free to email me. Okay.